Now, this is particular VC. That means particular cutting velocity this S curve is generated. Okay. Time of action. Time of action means tool life. Because when the at the very first time tool is contact with the job, this is our first starting point. Then when the mm, wire tool is completely the cutting edge of the tool is completely blank. This duration, the time duration between first time tool contact with the job and the principal cutting edge or cutting edge becomes blunt. This time duration, between this time duration, this is called life of the tool. Okay, in between we have break-in period, uniform wear, and catastrophic failure. So that life of the tool is to time of action means tool life in minute. So that this is the particular given velocity. This is our tool life because this is 5 minutes, this is 12 minutes, this is 20 minutes. Okay, the particular velocity of a particular tool, this is our 20 minutes, this is our tool life. Okay, okay, how we get this tool life? This is flank wear. The a standard value of flank wear is 0.3 mm. If the wire goes after 0.3 mm, then we call the tool life of the tool is over. Okay, this is our tool flank wear line. This is our tool life line. If this is standard, okay, this is valid for all types of tool, almost. If the flank wear goes after 0.3 mm, then we call the life of the tool is over. So that if this is our curve of a given velocity of a given tool, so that this is our 0.3 line. If 0.3 line cut here, then vertically perpendicularly will draw a line on the time curve or tool life curve. So 20 minutes, this is 20 minutes. Okay, now if you want to increase the cutting velocity, so suppose this is 500 uh, 500 mm per minute. Okay, now we have to increase the cutting velocity. We have to machining. We are going to machining the job in more velocity, more than 500. Suppose one. Suppose 1000. 1000 meter per minute, millimeter per minute. So the for 1000 millimeter per minute velocity, cutting velocity, there is another S curve because this S curve is valid to a particular velocity or particular tool. This is suppose we choose 500 millimeter per minute. So now for 1000 this is another curve. So this curve is more steeper. So that this S curve is more steeper. This is 1000 cutting velocity. Okay. This is 1000 point. Vc equals to 1000 millimeter per minute. Okay, now see that very important part. For a particular tool, when we choose 500 millimeter per minute, the cutting velocity or flank cutting, if we choose 500 millimeter per minute, then the flank wear point 3 reaches at 20 minutes. Okay, now same tool, we use same tool, but the velocity is increased to 1000 millimeter per minute. Okay, so this curve is more steeper, so that see the curve, the, in that cutting condition, the flank wear of the same tool reaches very fast, so that this is our 1000 millimeter per minute curve, so that it reaches very fast at this point, 0.3 mm. This is our point, so this is suppose 10 minute. The same tool we use in more velocity, this is the life of the tool become then 10 minute. If we choose lower velocity, then the life of the tool is more. This is for same tool. I am telling you for same tool. If we want to increase more or more velocity, suppose 500, 1500 rpm, this curve is more steeper, then the life is very small, tool life, because when the wire flank wire reaches 0.3 millimeter, then life of the tool is over. So that if we increase the velocity, so that the tool life is automatically decreased. If we lower the speed, suppose 200 millimeter per minute, then the curves become, the life of tool is more than 20. This is our curve. So in this direction, velocity increases, so that this is our relation between tool flank wire, tool life, and cutting velocity or cutting parameters. Okay, now it is all of this. Now scientist Taylor proposed one formula which is based on tool life. That is Vt to the power n equals to constant. V is cutting velocity, V is cutting velocity, and T is tool life or time of action. C is constant, which is depend on which depends on work material, tool material. Okay, this is index, cutting index. This also depends on work material and tool material. Okay, this is Vt to the power n. This is very important formula, Vt to the power n. Okay, V means cutting velocity. In our next lecture, we have discussed, or we will do